Hello, everyone, and welcome to this new video. This is a walkthrough for section 3.1, 3.3, section 3.3, the measures of position. We have walkthroughs for the other two sections, and we do have quite a bit of support content for this section, but some of you asked for a walkthrough, so I'm going to provide that here. In section 3.3, we're continuing our study of the statistical measures. So just to give you a tiny bit of context, because there's a lot of measures that go on in this chapter, and it can get a little confusing. We basically have three kinds of measurements that we go over. So in 3.1, we talk about measures of center. Sometimes we also call this the measures of central tendency. Where does the center typically fall? Measures of central tendency. And those are mean, median, mode, mid-range. There are others, but these are the ones that we typically go over. If you need help with what they actually are, go back to your notes or go back to the video and you can refer to that. 3.2 was about measures of variation. And so typically here, this is going to be measures of spread. These are measures of how the distribution is spread out, how the data values look when you graph them, if they're spread out widely or if they're clustered kind of around the same area. That gives you indications in the data set about certain things. You'll learn about that later. But in measures of variation, we talk about, the first one we talk about before we ever get here, and that's the range. We talk about the standard deviation. And we talk about the variance. And couple of points here. The range is probably the easiest to calculate, but it's also the most sort of affected by extremes, as you might expect, because the thing about the range is you're only using two numbers. So even if you've got 100 numbers in the data, you're only looking at the two. So the range is the most affected by extremes. So if you have a lot of extremes in the data set, and we'll talk a little bit about that later, you're going to have a problem with the range. Now, the standard deviation, as we mentioned in class, is an average distance from the mean. Sometimes the variance, for mathematical reasons, is preferable to the standard deviation, but this is a distance away. And typically, what you need to know for this is to get the variance, it's the square of the standard deviation. That's how it's calculated, and you know that already, but just to kind of give you some help with that. So those are measures of variation. And in 3.3, we're going to talk about other measures. We're going to talk about measures of position. And this is something that that I wanted to point out. There's a couple of things that I'm going to take you to the slides in a minute and point out to you. But 3.3, measures of position. These are measures that tell you where a data value or where a person's score falls in relation to everyone else in that group. So where are you in relation to that group? Measures of position are things like percentiles, deciles, quartiles, and the z-scores. Okay, there are others, as I said. Those are the main four, and we're going to talk some more about some of these in detail. One thing that I do want to point out that's hard for people is the difference between percentiles versus percentages. Okay, so a percentile describes how many scores are at the same relative, at the same relative position or below that position. So it's a measure of your rank, okay? Percentiles describe that, okay? Percentages describe a parts of a whole and without regard to where those points come from. So let me explain what I mean. If I say Ted received a grade of 80% on his statistics exam. Okay. Ted received a grade of 80 on his statistics exam. Well, that means that Ted earned 80% of the points that were available on that exam, right? This tells me how many parts, how many points he earned out of the whole. It doesn't give me any indication of his position in relation to everyone else. Yes, I know that he got a B more than likely if this is a straight scale, right? But I don't know how he did in relation to everyone else, okay? This just tells me how many points he earned out of the whole. If I change this and say, Ted scored in the 80th percentile on his state test, for example. What I'm saying here is, out of all the people that took this test on this particular day or in this particular group, he's at the 80th percentile. So what that means is 80% of the people who took that test scored at his level or below him. Okay, so I don't know maybe how many people took it, but 80% of the people who did it scored where he was or below. And only 20% of people scored above where he was. So this gives me an indication of where he ranks in relation to other people who did the same thing. Here, I just know that he got 80% of the points available. So I hope that clarifies. So the difference, because one of the questions, let me go there actually. Let me show you the I believe that I have the homework for this section. Let me go and share this for a moment, and I'll bring down the book, but let me bring the homework here. And let me share the homework with you. So the homework says, what is a z-score? We're going to come back to that in a minute. What is the difference between a percentage and a percentile? Well, I would say that so I would say in broad terms, okay, what is the difference between, okay, so question 2, we're going to come back to question 1. What is the difference between a percentage and a percentile? Okay, well, a percentage describes a part to whole relationship without any information about relative position. So you know how many points you got out of the whole or what part of the whole it was, but you don't know relative to other people how you did. A percentile is a measure of position relative to the rest of the group. Something similar to that. And I'll show you the place in the book where that occurs. Let me show you something here. I'm going to take you to the textbook here in just a minute. Let me do a new, here it is. You can see, if you look down, this is page 151 in your book, section 3.3. It says, percentiles are not the same as percentages. That is, if a student gets 72 correct answers out of a possible 100, she obtains a percentage score of 72. There is no indication of her position with respect to the rest of the class. She could have scored the highest, the lowest, or somewhere in between. On the other hand, if a raw score of 72 corresponds to the 64th percentile, then she did better than 64% of the students in her class. I hope that clarifies for you a little bit about it. Now, let me also come back. I wanted to bring that up, but I'm going to take some time now to go through some of the slides here. We're not going to go through them all in a great deal of detail, but one of the first things we were introduced to is something called the z-score, okay? This looks hard, but it's not as hard as it looks. The formula is pretty basic. Z is equal to x minus x bar. These are different. The notation matters. X minus x bar over S. Remember, S is the sample standard deviation, okay? And this is a measure of position. Where you see this, if some of you are psychology majors or maybe in medicine, something like that, where they do a lot of standardized testing, you'll see a lot of z-scores. If you know anything about special education or special populations, you'll hear about z-scores and what makes a z-score sort of expected and what doesn't. And we'll learn more about that in a couple of sections. But for the purposes of this brief introduction here, what I think you'll find easiest to remember, and this is usually the first thing that I show students to do, is when you're doing z-scores or standard scores, we have z is equal to, yes, it's x minus x bar, but I'm going to show it to you this way first. It's the score minus the mean over the standard deviation. That's essentially what's happening. Now, that's the formula for your z-score, okay? And so what's happening is we have the mean in the middle, we have the score, we're finding the difference between the two, and we're dividing by whatever the standard deviation is. So what we end up finding is how many multiples of the standard deviation away from the mean we are. That's essentially what we're doing. So a z-score is a number of standard deviations from the mean. Okay, so let's take a look now at, let's take a look at this first. I'm going to switch back to the homework problems, okay? We're going to talk about some of these other measures in a second. I'm going to look at number 5, okay? And look at number 5. If the average number of vacation days, so here I'm looking at, we're starting to get to a point in this class where everything means something, and I want you to remember that. Always read these problems like everything means something, even if you don't know why it's there. So the average number of vacation days has a mean of 29.4 days and a standard deviation of 8.6 days. Find the z-scores for the average number of vacation days in each of these countries, okay? So notice, we want to find the z-scores. So we need 3 things. We need, because remember our term, we're going to do Canada. Canada has 26 days. So I'm going to do this here. I'm going to say that this is number 5, okay? I'm going to say that, oops. Okay. I'm going to say number 5 here. We're doing Canada, and the average number of days. So the mean, remember, average and mean in this case are pretty much synonymous. The mean is 26 days. Okay. Now it says this mean here is the mean of the days that we're concerned about. So this is our score, essentially. And the average number of vacation days for a selection of various countries has a mean of 29.4. So what we're going to look at in a standard deviation of 8.6. So what we're going to look at here is we're going to say this. So we're going to do, this is going to be this number 5. This is number 5, and we're doing Canada right now, okay? So I'm doing Canada. here. So they gave us our score, essentially. We're looking for the score of the average number of days. Let me write the symbols next to this. So this is going to be equals x minus mu, x minus x bar. That's a minus. I know it doesn't look like it, but it is. Over s. Okay. So then we're going to look back and we're going to say this. Let's look at the homework. We have 26 minus 29.4. Okay. So you have, it's less than the mean for various countries, essentially. So here we have this. I'm going to have z is equal to z is equal to 26. Let me put it in the text so I can type it. 26 minus 29.6, I believe it was, right? Over 8.6 was our standard deviation from what we read. Okay. So that's how that setup would look. Now, let's take this back one more time. Um, 29.4. I'm glad I looked at it because I made an error there. Let me see. It's 29.4. So what I'm going to do is I'm going to fix this. I'm going to erase this. This is 26 minus 29.4 over 8.6. When you put this in your calculator, make sure to put parentheses around the numerator. So this is going to look something like this. I'm going to bring up the calculator. At this time, give it a moment to open. Bear with me for a moment here. I'm going to stop sharing my screen and I'm going to open up the calculator here and share the screen with you. So we now have this. Let me quit from here and clear all this out. Okay, so we now have parenthesis 26 minus 29.4 over 8.6. Okay, 8.6. That is, we're going to round this to 4 decimal places. So negative 0.3953. Notice there's a 4 in the next place. So because there's a 4 here, it's not big enough to change this. So my z-score is negative 0.3953. Negative 0.3953. So here, this comes out to equals negative 0.393. That's my Z for Canada. If I have a a number of vacation days that's larger than the mean for these other countries, then I'll get a positive number. Let's look at something else. Let's look at, we don't really have an A, a B, and a C here, but if you look at something like Italy, Italy has 42 average vacation days. So if you look at Italy, let me show you this. We're going to do a new share. We're going to do the same thing for Italy. So when we set up Italy, it's going to look like this. Okay. So we have Italy right here. And we're going to have a Z is equal to, formula is the same, the numbers are different. In Italy, the vacation days are 42 minus the mean for most of the countries is the same, 29.4 divided by 8.6. So we're going to divide here by 8.6. Now, we divide that. Let's go back to the calculator. We would expect this to be positive because Italy has more vacation days than this national average. So let's look at the calculator here, and we have 42 minus 29.4 over 8.6. So we get 1.4651. 1.4651. So here we have equals 1.4651. Okay. Now we're going to go to and do the last part of this question. In the United States, which is the last piece of this, the average vacation days are 13. Okay, 13. So 13 vacation days. Okay. So you have oops, my apologies. 13. So we're going to have in the United States, we have United States. We have Z is equal to 13. So this is going to be, and I could put parenthesis around each of these as I did on the calculator, just to remind you, right? It says, just to make sure that you maintain the order of operations. So you have 13 minus 29.4, and you're going to divide that by 8.6. Okay. So again, we would expect this to be negative because it's below the average for most countries. So let's do this calculation so we can finish the problem here. I'm going to share my calculator one more time. This is 13 minus 29.4. And I'm going to divide it by 8.6. This is negative 1.90697. Now, this is a good rounding lesson for those of you who may have some difficulty with this. So let me put it on the screen, 90697. So here, this is negative 1.90697. Usually when we round, we change one digit. We want to round this to 4 places after the decimal. So 9069. There's a 7 here behind this 9. And we want to look at this 7, okay? This 7 is larger than 5. This 9 typically would become a 10, but we don't have room for 10. So what happens is this changes to a 0 here. And then we carry this one over. So 69, in effect, these 2 digits change. And you only have 2 digits that change if you have a 9 in back of a number that's bigger than 5. You'll see 2 digits flip. So you're going to get 70 when that rounds. And then you're going to have, this is going to be negative 1.9070. So you're going to have negative 1.90 and then 70. Let me clean up let me clean that up for you so that it makes more sense. So we have, this is going to be negative 1.9070 if I round it to 4. Okay, so I hope that helps in terms of z-scores. So we've talked about percentiles, we've talked about z-scores. If I go back and I show you the measures of position here, you'll recall from class that percentiles divide the distribution into 100 parts. That's what percentiles do, okay? There are, and I'm going to remind you that that uses 99 slices or cuts, if you will. So you're not going to find 100 percentiles, you're going to find 99 because there are 99 slices. Deciles, think of decimal numbers. Deciles divide the distribution into 10 parts. Uses 9 slices. Okay. So deciles use 9 slices. And quartiles, as we had discussed in class, divide the distribution into 4 parts. And it uses 3 slices, okay? So that's how that works. Now there's a relationship between these things. So that's what we're going to talk about next. Let me go back to our homework assignment here. So with quartiles and percentiles, how are percentiles related to deciles? Okay, so here for number 3, let me put it on the screen. If your decile is divided into 10 parts, then every 1 decile is 10 percentiles. In other words, this is what we're saying. We're saying that, for example, let's do this one. So let's say like decile 10, and I'm going to put it below it. Decile 1. So the first decile, that's 10%. So this is related. This is P1, for example, right? This is going to be P10. Decile 1, because deciles, there's only 10 of them. So the first decile is the first 10 percentiles. Usually what we want to write, for example, is I would say every 10 percentile is 1 decile. Okay, every 10 percentiles is 1 decile. And of course, D2 would be P20 and so forth, right? What is the relationship between quartiles and percentiles? Okay, so every 1 quartile is 25 percentile, okay? Because again, quartiles divided into 4 parts. Now, typically what you're going to see her do is she's going to write something like this. She's going to say P50, so the 50th percentile, right? And then you're going to have to fill in the proper quartile. Well, if P50 were in the middle of the distribution, so P50 is going to correspond to Q2, which is the median. Okay, so Q2, P50 is Q2. And that's also equal to D5, decile 5. Okay, so something like this is what she's looking for in terms of your relationships between the numbers. Okay, so I hope that kind of clears up those first few. We talked about number 1 and number 2 already, okay? But this is something that you need to know. The 50th percentile is the same position as the second quartile or the median, which is the same position as the 5th decile, okay? So let's move on now. I'm going to clear the drawings here. Number 6 is more about z-scores, so I'm gonna let you work on that one. We're going to continue down. Number 7 is another relative position, okay? The thing to watch out for in number 7 is that you have a score of a 75, so that's your score, with a mean of 60 and a standard deviation of 10. That's straightforward. But here, a score of 36 on an accounting test with a mean of 30, be careful, and a variance of 16. Remember here that when you put this in the formula, the variance is the standard deviation squared. So if you put this in your calculator when you do the second one, remember here, remember variance 16 implies, variance of 16 implies that standard deviation is the square root of that number. Standard deviation is 4. So remember, you're going to use 4 in that case. You're going to compare them, and you want the better relative position. Okay. I'll let you work on number 8. It's a lot like number 5. The average miles driven annually is approximately that. If we assumed a fairly mound-shaped distribution, again, mound-shaped, bell-shaped, symmetrical, those are all synonymous terms for that curve that we know of. And it's also called normal. So normal refers to the shape of the curve. I'm going to let you work on those. That shouldn't be too problematic for you. Okay. If it is, by all means, feel free to ask questions, but it should be fairly straightforward. Let's continue to the next part of this. Okay, number 9, you have percentile rank, okay? I don't remember which of these problems I did in the video, but there's a dedicated video for one of these problems. I think it might be number 9. I did number 8 as well. But I also did one of the percentile rank problems, and I don't remember if it was 9 or 10. Okay. But they are there. Now, find the first and third quartiles, and 13 is check the set for outliers. Just for the sake of doing it, I'm going to go ahead and do number 9 in this video for you. So what I'm going to do here is I'm going to do this by hand for you, but I'm also going to put this in the calculator so I can read the numbers, because I'm going to need some calculator assistance. Whoops. Going to need some calculator assistance with some of this. So I'm going to, I went a little crazy with the with the screen share. Sorry about that. So let me do this. Let me put this on the screen. Okay. Okay. So number 9, anytime you're going to do any of this, you're going to rank the data first. So you want to put this data in order. So I'm going to put this in, and I'm going to say, I'm going to do it below it so I can see what's going on. Now I could have the calculator do it, and I think I'm going to, just because I want to show you that. So I'm going to take my calculator here, share it, and I'm going to I'm going to see if I can move the screen over for my own sake here. I think we're good. But I need to do it over here, I believe. Okay. I'm going to do this, and I'm going to do that. And I'm going to stop sharing my screen so I can maximize this. Okay. So I'm going to, let's see, there I go. I can make that work. Now let's see if I can show both on the same screen. I don't think you can see, maybe you can. I'm not sure if you'll be able to see both on the screen here, but I can. So what I'm going to do is I'm going to put those data in my calculator. So I'm going to go ahead now and clear this. So I'm going to clear my screen, and I'm going to move this up also, because I need to be able to I need to be able to see the screen, and I just lost my homework. Let me put this back. There it is. And then move this up just a bit so I can see the okay. Well, here's my data. Okay. Need to move my locations over. So we've got, there's my data. And I think that's everybody. Yep. Okay. So number 9 is, I'm going to go to my stat, and all I want to do is sort this. So I'm going to go ahead and clear my data. So I'm going to go, the other thing you can do besides clear and then L1, if you're clearing one list, go up to the top, hit your list, and then go clear and enter. That will also clear your list for you. So here I go, 804, 804, then I have 736, 659, 489, 777, 623, 597, 524, and 228. Okay, those are my scores, and I want to find the percentile rank for each one. So I'm going to start by stat. I want to sort ascending. So I'm going to go sort A. I'd like to sort L1. So second, the number 1 here. And close, whoops. And close the parenthesis. So enter. Go back. And my list is now sorted. Now, I'm going to show you this. I want to find the percentile rank of each value. So I'm going to have as many answers as I have values in the list. And you're thinking, oh, that's going to take forever. Not really, because it's a pattern. So let me show you something. Let's go to the slides for a minute. Here, I'm going to show you the slides. We're going to go and we're going to look at, here's the percentile rank. So what we're going to do is we're going to say it's the number of values below X, that's my given value, plus 0.5 divided by the total number of values times 100. Now I'm going to stay on this slide and I'm going to write on it directly from our values. Now, if you remember, let's go to the calculator here. We need a couple of things. We need to know, I'm going to do the first value. So it's 228, okay? I need to know how many values are in the list. So if you count, there are 10 values in this list. I'm sorry, there are 9 values in this list. Let me make sure that that's actually accurate. So let's go back to the homework, make sure I didn't miss anything. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 values. Let me make sure that I didn't miss any, as I said, but I don't believe so. 228, no, there are 9 values. So this is what this is going to look like. I'm going to say, here's what this formula turns into. This is going to be, let me annotate on the screen. This is going to be 4x equals 228 for the last problem that we started. Okay, we're going to have how many values were below 228? Now, don't confuse yourself. This means values in the list that were below that, not numbers when we're counting it. This refers to values in the list. There weren't any. So here we're going to have percentile is equal to 0 because that was the minimum plus 0.5. And this has to do with the correction for the percentile calculation itself. And then the total number of values is 9. So we get 9, and then we multiply that by 100% here. So this is 100%. So what this comes out to be, we have 0.5 divided by 9 times 100%. So what I'm going to do now is I'm going to share the calculator, okay? And 0 plus 0.5, I'm going to quit from my stat screen. 0 plus 0.5 is 0.5 divided by 9. There were 9 values times 100. So that first percentage is 5.5556. So we have, let me come back to this here. This is number 9 on our, this is number 9. And I'm going to do, there's a total of 9 values. And we have for x equals 228, we have the percentile is equal to 0 plus 0.5 divided by 9 times 100. Okay. This is times 100%. Okay. So this is going to be 5.5556%. Okay. 5.556%. Now, when I get to the next value in the list, which is let's go back to our data, stat, edit. It's going to be 489. There's going to be one value below me again. It's not how far apart they are. It's how many values are in the list below that. There's one value below it. So we have, for 489, we're going to get for x equals 489, we have percentile is equal to 1 plus 0.5 divided by 9. And that's equal to, or sorry, times 100%. And if we work that out, let's work that out, see what we get. We have, this is, let's clear this. So we get, let's quit from there. So we get 1.5 divided by 9. And that gives us 0.1667 times 100. This is, oops, what happened? Did oh, I have 2 multiplication signs. 16.6667. So this is 16.6667%. That's your percentile. You would continue that for the other numbers, okay? The only thing that's going to change in every calculation is this first number. It's going to go up by 1 because there's going to be one more number below that, okay? You're going to have 9 answers in total to this part of the question, okay? So if you look, let me show you something. If we go to the homework, and I'm going to go ahead and minimize the calculator screen and maximize the homework for a second. If I scroll down here and I look at it, I have this is number of values below X. There are 9 answers for this. I believe there's a typo here. Let me see what this last answer is. This 6th, because she ranked them in order from, this is the percentile. She rounded to the nearest, but she has it in reverse order. So 5.5556 is going to be the 6th percentile, right? But those answers, there's going to be an answer for each one. And I haven't shown you the percentile, so I will take a look at that. And I'll get back to you. I'm going to pause. What you're going to see here is the solution Professor McDowell has for the problem in question. And as you can see, as I stated, she rounds this to 5.6. She rounds the second one to 16.7. And you continue the pattern. 2 plus 0.5, 2.5 over 9, 27.8. And then for 597, 3, and then 38.9, and so forth. And we do that for the whole list. 623 is 4 plus 0.05. We have 50th. We have 61.1st. We have 72.2nd, and we have 83.3 and 94.4 or 95. Now those are the percentile rank. There's a second part to this question, which I wanted to show you. So let me come back now to the problem that we're doing here. We come back to the homework here. I showed you how that is 6, 28, 39, 50th, 83rd. It wouldn't be 17th. This is a different number, but she rounded to the nearest percentile, 6, 28, and so forth. But let me show you the second part of this, which is for the same data, what value corresponds to the 40th percentile. Now, if you're doing percentiles, okay, there's a difference between percentile and percentile rank. So if you go to the next slide here, 2 slides, on slide number 7, finding the value corresponding to a given percentile. Let P be the percentile and be the sample size. Remember, we have 9 data values. We're looking for the 40th percentile. So in this case, in the problem that we're doing here, I'll do it for you on the screen. We have 9 data values. So this is 9 data times the 40th percentile. Here you don't want to make this a decimal because you're already dividing by 100. So leave it at 40 here, and then you divide this by 100. This is the formula, okay? So you're going to end up, if you do this calculation, this is going to end up being 360 over 100. Okay, and that's 3.6. Now, the reason I wanted to do this here is because I wanted you to see the calculation with the rule. So this is 3.6. Now, L is not a whole number here. L is a decimal. So we're going to follow the first bullet point, okay? Which means that we're going to go back to our list, and it says, if L is a whole number, the whole number versus not a whole number. So if you look at the third bullet, you round up. So what that means is that our location in this case, your location is equal to 4, okay? So what we're going to do now is we're going to go back to the homework. We're going to go back to the homework. And actually, I'm going to go to my data list because my list is sorted. So I'm going to go back to that and share with you my calculator screen. Share the calculator screen here. Stat, edit. And since L was 4, the number in position 4 is 597. So her last answer was correct, but her percentiles were slightly off. She rounded to the nearest percentile. But I hope that helps with that question. And we're also going to do one more question about outliers before I leave you. There's more about outliers on the video for section 3.4. So there's more nuanced discussion there about that. But let me, before I leave you for this video, let me going to talk about outliers and the interquartile range, IQR. Okay, an outlier is an extreme data value, either large or small compared to the other data values in your data set. Okay, we have some procedures that we have to follow to decide if a data value can be considered an outlier. We might have a suspicion one way or the other, but we have to follow this procedure to find out for sure. So we're going to find Q1 and Q3, and we're going to do that by hand initially with that. And then we're going to find the IQR, the interquartile range between quartiles, between Q3 and Q1. Then we're going to compute this term 1.5 times whatever this IQR is. This is really like an error term, and this will become more meaningful to us when we get to box plots in section 3.4. But this is really like our error, and this is where and then we're going to calculate our lower and our upper boundaries. So something that is smaller than Q1 and larger than Q3 would be considered, so Q1 minus 1.5 times this IQR, Q3 plus 1.5 times this IQR. Anything here would be considered an outlier. So I'm going to show you something at this point. Let me stop sharing this and come back to you. To finish this video, I'm going to show you problem 13A. Okay, not going to do B and C. I'm going to do A. B and C are similar, but if you can follow A, then you can do the rest. I'm going to show you the steps for finding outliers again. So first, we compute Q1, the quartiles in Q3. Okay. And if we're doing this by hand, then we're following this example where we arrange the data in order. We find the median of the entire data set, and then we find two other medians. So I'm going to show you that now. So what we're going to do here is I'm going to come back here. And I'm going to start by, you can use the calculator to help you sort these, but she wants you to do this by hand. So the first thing you're going to do, sort the data. So I have 3 here. And then I have, let's see, looks like 17, 16, 17, 16, 17, 18, 19, 20, 21, 22, 16, 18, 22, 19, 3, 21, 17, and 20. So I have 3, 4, 5, 6, 8 numbers. 3, 3, 6, 8 numbers. So there's my sorted data. Okay. And just to make a note, I have 8 values. And if you remember from the lecture today, when I have an even number of data values, then I'm going to have my median be 2. So what's going to happen with this? Now, some people cross them out. Some people just note them in other ways. It depends on how you learned it. I'm going to underline here 1 high and 1 low. We're looking at the middle here. So remember from our data set that if I go back to my slides for the location of the median, okay, let's look at it. We have the median here. Oops. I want that slide, but not right now. What I want is I want to find my median, which is back in 3.2. If I have an odd number of data values, then I'm going to have 1 middle number. If I have an even number of data values like I do here, then I'm going to have 2 middle numbers. And I'm going to show you that informally first, and then I'll show you the formula. So this is a small number and a large number, then a small number, then a large number, then a small number, then a large number. And you keep going until you can't do this anymore, and you'll see that you have 2 middle numbers right here. Now, that was practical to do on a small data set like this. It's not practical to do on a larger one, okay? So remember our formula here for the location of the median is going to be n, which is 8, plus 1 divided by 2, right? And if it's two numbers, two middle numbers, and I do have two middle numbers here, then I have n over 2 as well, right? So I've got 8 over 2, which is 4. So I have this first middle number would be 18, which if you remember from what I showed you before, this middle number is 18. And this other middle number, 19. So you get, so we have halfway between the two middle numbers. So what do? You say that the median of the whole data set, is going to equal 18 plus 19 divided by 2, which is 18 and a half, okay? Now, we need to find the quartiles, okay? So the next thing we do is we find the quartiles. To do that, we have now this new list. Let me write the list again because I want to show you something. You have 3, 6, 16, sorry, I think I said 6, 17, 18. Now, here's a question that happens, and sometimes the book will ask you this. I'm gonna do something here and change this. This is 18 and a half was our median, right? Notice that our median wasn't in our original data. That is perfectly fine. You can have a median that's not in your data set, and we do. 19, 20, 21, and 22. 20, 21, and 22. Now, what we're going to do here is, and there's a reason why I put this data value in red. What we're going to do now, this red 18 and a half, this is Q2. This is our median, okay? But we need to find our quartiles. So what we're going to do is we're going to repeat the same procedure, but we're going to do it on two separate lists. We're going to find the median, but for all of the data values in the smaller list. So for Q1, we're going to look at, for Q1, we want the median of, the list 3, 16, 17, 18. And as you can see from there, again, we're going to have two middle numbers, right? So we're going to have, that's going to equal the median here, which is Q1, quartile 1, is going to equal 16 plus 17 divided by 2, which is 16 and a half. Okay, this is our data. So we have 16.5 as our Q1. Now we're going to do for Q3, we want the median of Q3, we want the median of the list from 19, 20, 21, and 22. 19, 20, 21, and 22. And as we can see, that one is going to be 20 plus 21. So Q3 will be 20 plus 21 divided by 2. This is 20.5. 20.5. So now we have our data. Our median is 18.5. Our Q1 is 16.5, and our Q3 is 20.5. We need all of that in a minute. So 16.5, 18.5, and 20.5. I'm going to move my whiteboard along at this time, and I'm gonna write some numbers for us here. So Q1 was 16.5. Q2 was 18.5. And Q3 was 20.5. Okay, those were our results from the lab. Now, the next step in finding outliers is to find the IQR. So we're going to find the IQR. And again, that's always Q3 minus Q1. So we have, this is Q3 minus Q1. And so we have 20.5 minus 16.5. And that becomes 4. So the IQR here is 4. It can also be a decimal. It doesn't have to be a whole number. It just turns out, in this case, to be a whole answers. This is 4. Now, that's our IQR. The next step is to find the error term. So she doesn't give it a name, but we're going to find 1.5 times the IQR. Now we just calculated the IQR here. So we're going to say that that's 1.5 times whatever that difference is that you found in the last step. In our case, that's 4, and that is going to be 6. 1.5 times 4 is 6 units. Now what we're going to do is the real nitty-gritty work of finding outliers. We're going to find the boundaries that define what expected data from outlying data would be. So to find your lower, to find your lower boundary, you're going to do Q1 minus 1.5 times the IQR. Now, that's why we calculated it. Okay, that's why it's there. So Q1, remember, is 16.5. And 1.5 times the IQR is 6. So I'll write it like this just to maybe make it less confusing and more accessible to you. This is 4 here. So we have 16.5 minus 6. Okay, minus 6, sorry. Minus 4. I apologize. This is 4. And so we end up with 16.5 minus 6. Okay. And that is 10.5. So my lower boundary, this is 16.5 minus 6, which is 10.5. And that is your lower boundary. So now I'm going to do the upper boundary, and then I'm going to explain this. So my upper boundary is going to be Q3 plus 1.5 times the IQR. And so I end up with 20.5 plus 1.5 times 4. And again, that's 6. So 20.5 plus 6 is going to be 26.5 units. Now, what you have to do at this point, we have to go back to the original data, okay? And what we're going to do is we're going to ask ourselves, remember our lower boundary was 10.5, our upper was 26.5. So if we go back to the original data here, okay, where I sorted it, 3, 16, 17, 18, without the median in there, the data itself, 3, 16, 17, 18. So it's here's my data set. 3, 16, 17, 18, 19, 20, 21, and 22, right? Here's what I asked myself. I say, okay, I calculated my lower boundaries, my upper boundaries. Are there any data values lower than or less than the lower boundary? Yes or no? Well, the lower boundary is 10.5. 3 is less than the lower boundary, so yes. Okay. Are there any values higher? The other question I asked is, are there any values higher, or greater, I should say maybe, greater than the upper boundary. In this case, that answer is no. In this first case, we had yes, 3. And in this case, we had no. Now, you could have yes and yes, you could have no and no. If you get a yes, you have an outlier. So yeses mean outliers. And so in this case, the outlier is 3. And that's how you find outlier. You could have outliers on both sides. You could have multiple outliers on both sides. You could have no outliers. This list had one outlier on the lower side. This video has gone on for a really long time. Thank you for sticking with me. I hope that you learned something. I hope that you found this video helpful. And I will see you very soon in my next video. Thank you, folks. Take care. Bye for now.